This is my sixth video lesson for Unit 12. In this lesson, we'll be using Q to determine the direction of a reaction approaching equilibrium. Go to page 27 in the class packet. Keep in mind, this topic is not on the Chemistry Regents exam. Motivation: if the K constant is 5.1, does the reaction shift reactants or product if each species is initially 1 molar? Keep in mind, this is not equilibrium concentration. It is the initial concentration. Since the initial concentration of each species is the same, we have to use Q to determine which direction the reaction will shift as it approaches equilibrium. Learning target: at the end of the lesson, I will be able to use reaction quotient Q to determine the direction of a reaction approaching equilibrium. Homework B number 6, which is based off this lesson. Reaction quotient Q gives the ratio of the product concentration to the reactant concentration at any point in the reaction, so it's not necessarily equilibrium. So in this reaction, Q has the same equation as the K constant, but this could be at any point, not necessarily equilibrium. It is just a ratio between the product and the reactants. So when Q is equal to K, the reaction is at equilibrium. In questions, Q uses initial values while K uses equilibrium values. This graph shows how the concentration of each substance changes as a reaction approaches equilibrium. Q can represent any point during the reaction. Think of Q as a snapshot of the ratio of the products and reactants during the reaction. Before the reaction reaches equilibrium, Q is currently less than K, but as the reaction progresses, Q will change until it's equal to K. So to figure out which direction the reaction will shift, Q will keep changing until it's equal to K. So Q will always shift towards K. For example, if Q is less than K, if we use a number line, the value of Q will increase by shifting right. If Q is equal to K, there won't be any shift because the reaction is already at equilibrium. If Q is greater than K, the value of Q would decrease by shifting left. In summary, when Q is equal to K, the reaction is at equilibrium. When Q is less than K, there will be more reactants than products and will shift to make more products at equilibrium. If Q is greater than K, there are more products than reactants and it will shift to make more reactants at equilibrium. If Q is equal to 0, Q will always be less than K. It will shift to make more products at equilibrium. If Q is equal to infinity, Q is a very big number and it will shift to make more reactants at equilibrium. So we are going to use simulation 1 from page 16 to illustrate this. If you recall, this is our reaction. The K constant is 1.33. Initially, we have 14 reactants and 0 products. At equilibrium, we have 6 reactants and 8 products. If we set up a rice table, the initial amounts of reactants is 14, the initial amounts of products is 0. Q is equal to products over reactants, so Q is equal to 0 over 14, or 0. Since Q is less than K, it means the reaction will shift products. It will shift to the right. Since it is shifting towards the products, the amount of products will increase and the amount of reactants will decrease. This further confirms that the reaction will shift towards the side with no molecules. Now let's look at simulation 2 with a different starting amount. The initial amounts of reactants is 4, the initial amounts of product is 10. Q is equal to products over reactants, which is 10 over 4, which is 2.5. Since Q is greater than K, it will shift to the left. It will shift towards the reactant side. Since it is shifting towards the reactant side, the amount of reactants will increase and the amount of products will decrease. To figure out what X is, we have to use the K constant equation. K is equal to 1.33, which is equal to products over reactants. 10 minus X over 4 plus X. If we use algebra to solve for X, we get X is equal to 2. We can plug in X to the last row. We get the reactants as 4 plus 2, which is 6, and the product is 10 minus 2, which is 8. These are the amounts at equilibrium. Now let's go back to the motivation. Learning check number 1, where does it shift? Pause the video, resume completed, it will shift towards the product side. So here's our rice table. The first step is to figure out the value of Q. Q is equal to products over reactants, so H2 times CO2 over CO times H2O. If we plug in the initial concentration into the equation, we get Q is equal to 1. We're given that K is 5.1, so Q is less than K. If that is the case, it will shift towards the product side. You can use a number line to help you figure this out. Once you figure out the shift, you can fill in the change row. So the amount of reactants will decrease, so it'll be negative X, and the amount of products will increase, so it'll be positive X. Learning check number 2. Given this information, where does the reaction shift? Pause the video, resume to complete it. It will shift towards the reactant side. The first step is to figure out the value of Q, which is 90. 90 is much greater than the value of K, which is 1 times 10 to the minus 5. Since Q is greater than K, it will shift towards the reactant side. Learning check number 3. Given this information, where does it shift? Pause the video, resume completed. The answer is choice 3, products. The first step is to figure out the value of Q. Q is the ratio between products and reactants. Q is equal to 27.2, which is less than K. K is 1.59 times 10 to the second power. Since Q is less than K, it will shift towards the right, the product side. Learning check number 4. Given this information, where does it shift? Pause the video, resume completed. The answer is choice 2, it is at equilibrium. The first step is to figure out the value of Q. Q is equal to 0.5. Since Q is equal to K, the reaction will shift neither direction because the reaction is already at equilibrium. Try to do questions 4 to 7 by yourself. Pause the video, resume completed. Here are the answers. Going back to question 1 in the motivation, now that we set up our rice table, we can calculate the equilibrium concentration of all species. So to do that, we need to first set up the K constant equation and plug in the equilibrium concentrations. We get K is equal to 5.1, which is equal to this expression. To figure out what X is, we take the square root of both sides. We get 2.26 equal to this expression, and then we solve for X using algebra. We get X is equal to 0.387, and then we plug it in into the equilibrium concentration. So here are the equilibrium concentration of all the species. Try to do the rest of the questions by yourself. Pause the video, resume completed. Here are the answers. This concludes the video lesson. Remember to do the homework.